Next up, we have a very interesting talk. Gentleman, all the way from Poland. I'm actually not sure exactly how I'm going to.
All right. So, hello. Today I'm going to talk about abusing and securing XPC in macOS applications. So, my name is Wojciech Regula, and I'm a senior IT security consultant employed at Securing. Securing is an application security company. So in my work, I'm mostly focused on the iOS applications pen tests. You may also know me from iOS Security Suite, an open source tool mentioned to improve your iOS devices security. And after my professional work, I run a blog with my name, that blog. I made a research on XPC in macOS applications, and it turned out that the XPC-related vulnerabilities are everywhere. And even as Scott Knight mentioned, it was it was even in the macOS Catalina in beta in one of its services in Security Extension Framework. Security endpoint security framework, right? Oh, no, sure. And so, as you can see on the slide, many well-recognized logos. And the plan for today's presentation is, at first, I'm going to quickly introduce you to XPC. Then we are going to start building a secure XPC helper. Then we'll try to exploit the previous step. Then we'll try to harden that feature, and if the bypass is still available, we'll go back to the beginning, and at the end, if the loop is passed, we'll go to the summary. So the XPC as a fundamental interprocess mechanism in Apple environments, it is built on top of Mac messages. And Mac messages can be compared to Unix spies, because you can have multiple senders and only one receiver. It's also a dictionary-based communication, and it allows you to serialize the Objective-C and Swift objects through the XPC. But let's see at the code of the helper that we are going to build. At first, we are creating the NSXPC listener with the Mac service name that is a globally recognized name after creating it. Then we are going to create the delegate, which is a piece of code that will be responsible for handling the incoming XPC connections. Then we, of course, resume the listener and start the main loop. From the client perspective, at first, of course, we need to create an NSXPC connection object and connect to the Mac service name. Then we set the remote object interface, which the object on the other side, on the server side, has to conform to. Then we, of course, resume again the connection, set the remote object proxy with the error handler, and we ask the XPC server to perform our privileged action. But in this talk, we're going to focus on a specific architecture when unprivileged application, so typical application, tries to connect to the privileged XPC server. And by saying privileged and unprivileged, I mean unprivileged is running with standard user permissions with UID equal to 501, and of course the server runs with the root permissions. By the way, the windows below are from the privileged helper that we are going to build. And the locations of the XPC servers, they are stored in the library in privileged helpers, tools, and launch daemons subdirectories. There will be mostly the privileged ones, and the launch agents which will store the standard users' XPC servers. You can, of course, go to this directory, list it, or use knock to see if any of these privileged servers are running on your Macs. But it's only a 25-minute talk, so we are gonna focus on exploitation. And the first category of bugs that I've prepared is no client validation at all. So our malicious application asks the server to perform the privileged action, and the server says, all right, I will do it for you, without any verification. And that was a case in Keybase. That was a neat bug found by Adam Chester, and Keybase's XPC server exposed following methods. The most interesting one for me is here move and kext install, but let's focus on move. And as you remember, the server is running with root permissions. So this exploitation of this bug led indirectly to local privilege escalation, since any application could move any file to any root accessible directory. So you could, for example, override the SSH keys or just place your own XPC server that will, perform any action that you would send to it. And the fix for that, of course, the server now checks for the code requirement. In our privileged helper, we are adding a new if with validation logic. So in the listener should accept new connection method, we are performing the validation. If the client is validly verified, we return true. In other case, we return false and invalidate the XPC connection. But when we are talking about validation of the process, we also in our industry think about cryptography. And since it's cryptography, a lot of bad things may happen here. So the second category of bugs is poor signature check. And the examples of that poor signature checks may be checking only bundle identifiers, verifying only static code, using this KSEC CS basic validate only flag, which will only make sure if the application has been signed with a certificate, but not even if the certificate is trusted or it's not. Tools, sec requirements, string that I will show you on the next slide, and many, many more. And here I wanted to mention that I, of course, reported all the findings that I will be showing you in the next slides, and the vendors were informed, and I asked if they are okay with disclosing it, so it's a responsible disclosure. But let's come back to the topic. In Secure Mac in MaxCan3, there was also a problem with XPC. As you can see, they highlighted the sec requirement string. It only checks if the bundle identifier is equal to com secure mac maxcan3, and in the signing certificate that was a field with the team ID that is equal to that string. But this is a question for you. What was wrong with that string?
I can create my own identifier and signature. It's not checking the whole chain.
Yes, indeed. It does not checking the whole chain. So you could just use OpenSSL, create such a certificate with the team ID, and sign with the bundle ID, and this requirement will be passed in this case. Yeah, you're right. And the MaxCan3 exposed following methods. The interesting one is, for example, the cancel scan. So I wanted here to show you that exploiting the XPC servers doesn't always mean local privilege escalation. It may also have a business impact on your applications. So, for example, here, of course, it would break the MaxCan3 by canceling the scans. So, in our privileged helper, we are now adding the prefix unsure Apple generic, which will make sure if the whole chain is trusted, as you said. All right. The third category of bugs is using process identifier to get the code objects. And here I wanted to thank Samuel Gross, which is not present, as you can see now, and Ian Beer for sharing their research on it. and saying that, showing that the process identifiers are not really reliable to create the code objects. But to easily imagine that situation, let's see on that example. We have a malicious application that asks the server to perform the privileged action. And now we know that we have to somehow validate the client. So the connection, of course, will be invalidated because the signature doesn't match. And let's look at the general validation algorithm. So in the first point, we are getting process identifier of the client, and then we create the code object based on that process identifier. We perform the signature check, which will of course fail because the signature doesn't match for the malicious application, and we invalidating the XPC connection. But what if the malicious application forks a lot of time, had a lot of children that have other process identifiers, and in the same time, all the children sends the privileged action request to the XPC server. It won't be able to to process all the connecting messages in the same time. So it will be placed into XPC queue. And the algorithm now looks like as follows. The XPC server pops the connections from the queue with the privileged action request, and performs, of course, the general validation on it. But in the same time, the malicious application may do following trick. It may change the process image to legit executable using that POSIX function. So we are inside the same process. The malicious application loads the bytes from the executable that is stored on your device into the process. So we are in the same process identifier, and the action is popped from the queue. It now will be checked on the valid bits, right? So the validation will be here bypassed because we were using the process identifier. So it looks as follows. This is of course a race condition bug because this is a time window when the malicious application needs to swap its memory. And it was a case in, for example, Avast cleanup that was attached to the Avast antivirus. And the cleanup was exposing following methods, for example, the copy with source, which is the similar case as was in the Keybase, right? Local privilege escalation, because we were able to move any file to any root accessible directory. And as you can see, the process identifier was here. Another case in Malwarebytes, their server exposed a lot of methods. And for example, the uninstall product or stop the scan job were the most interesting ones here. So any application installed on the device could bypass the Malwarebytes antivirus and stop the scan, or even uninstall the whole antivirus, right? And as you can see, again, the process identifier in the decompiled code. But here's the question. We need to create somehow the code objects, but we cannot use process identifier. So Samuel Gross and Ian Beer figured it out that we can use audit token for that purpose. And the problem with audit token is that the first problem, it's a private property, so we cannot access it. And the second problem is that for implementing the helper, we've used Swift. And in Swift, accessing the private APIs is not that easy like in Objective-C. So in our privileged helper, I decided and consulted with our speaker that it's fully legal to use a bridging header to Objective-C and manually create the getter for the private property. And then I created the audit token hack class with the get audit token data from NSXPC connection method to retrieve the audit token encoded in NS data back to the Swift. All right. And on the Swift side, it's pretty simple because we are getting the audit token data and then creating the code objects. So the fourth category of bugs that I've prepared for today, the last one, is no-code injection prevention. Now our general validation algorithm looks as follows. We are now aware that we cannot use the process identifier, so we use the audit token of the client, and we create a code object based on that, and then perform the signature check. So unfortunately, there is yet another thing that may happen wrongly in that point, because as it turns out, the Apple signature checking API won't detect if any code has been injected with built insert libraries or the task for repeat method either. And that was a case, for example, in Lulu, our firewall. Lulu's server exposed following methods like add rule or delete rule, because it's of course firewall. Here is the fix. I have to say that Patrick was incredible because he fixed that in 1 day or something. Yeah. So now in the sec requirement string, now Lulu checks if the bundle identifier is valid and if the minimum version string is equal to 1.2.0. So why we are checking now the minimum version of the client? Because this is the minimum version when the hardened runtime was turned on. And in macOS Catalina, there were some changes regarding the quarantined items. Vlad Metnew has a talk today about the quarantine, right? So you will expand this topic. But for now, we need to know that all new applications that are downloaded from the internet require notarization. And the notarization enforces the hardened runtime to be turned on. And the hardened runtime will protect you against the local privilege escalation vulnerabilities in somehow, because, for example, it will not allow to load unsigned dylibs. And in abstract, I promised to share my trick regarding the injection of unsigned dylibs on macOS Catalina, and the trick is really, really obvious. Here is the whole magic. So if we have the validation based on the sec requirement string, and the sec requirement string is built on the team ID of the certificate, you can just inject to another app from the same company because it's still signed with the same certificate, right? So it's not a problem at all. If the sec requirement string also checks for a bundle identifier, you can Google for the application, for the older version of the application that has now the hardened runtime capability turned on, and simply again inject to it. And also you can look for the following problematic entitlements, for example, the get task allow or disable library validation. So even if you turn the hardened runtime on, if the disable library validation is set to true, you will be still able to load an unsigned dylib into the process. And here is the proof of concept of exploitation Lulu. So we are, as you can see, the rule set is now empty. We are opening the HTTP process that will be connecting to my blog. I block it. Here is the block message. The result will be the connection has been blocked by Lulu. And then we are checking if the Lulu has been signed with the hardened runtime capability. It's now, of course, yes. And when we try to insert the library into it, or malicious library, of course, unsigned, it will be blocked because, as expected, the hardened runtime is turned on. So let's now check if the text viewer was signed with the hardened runtime. It was not, the flags equal to 0, but it is still signed with the Objective-C certificate. So we now inject into it. Yeah, it was successful. And now again, let's try HTTP process. The Lulu has been bypassed and we received the data. Let's now see how it looks in the user interface. And as you can see, now it's set to allow. All right. So in our privileged helper, the fix, we have to check on the server side if the connecting process has the hardened runtime flag set. And of course, some problematic entitlements, as I mentioned before, also need to be checked. All right. So the summary. As I wanted to show you during this presentation, there is a lot of things that we have to remember about during creating the XPC server. So it's really painful and complicated. So especially for you, I've prepared a guideline that will help you creating such services. I will give you a few seconds to take a photo if anybody of you wants to do it. You have a question?
Is there a guideline published for the procedure of validation at this point?
Could you repeat?
Is there a guideline published for the recommended procedure of validation when you're using XPC? Like, for instance, it seems like having XPC helpers signed with the organization means that anything you release in that organization with the same signing certificate is a big vector.
I'm not sure if I understood you correctly, but if you check for the bundle identifier, even if the other applications were signed with the same certificate, it will only restrict, the second kind to that bundle identifier, as Patrick did, for example. The Lulu now checks for if the connecting service is exactly Lulu, right? Did I answer the question? Okay. And because we love open sourcing stuff, I've also decided to open source the source code of the privileged helper, so stay tuned and check our GitHub because I will release it shortly. And I also wanted to say that the validation in that helper is made modular, so if you want to train yourself and learn to XPC exploitation, you can just comment some if statements and it will be easy to learn. All right, here is the references. And that's all that I prepared for you today. If anybody wants to have this presentation on an email, I can send it to you. Just leave me your business cards and send me a message on Twitter. But for now, thank you.